Welcome to the Math 1050 Chapter 5 review. Let's go ahead and get started. The first thing I have here is some formulas, most of which will be used for Chapter 5. If you look at all these formulas below my wavy line here, these are all formulas for conic sections. The first being for a circle, the second two being equations of parabolas. If a parabola opens up or down, we use this first formula. If a parabola opens left or right, we use the second formula. Then we move down to the one and only formula for an ellipse, followed by two different formulas for hyperbolas. The first being with x minus h squared over a squared appearing first in our formula. That would give us a horizontal hyperbola. And a horizontal hyperbola is going to open left and right. Secondly, if we start with y minus k squared over b squared, we have a vertical hyperbola, which is going to open up and down. We'll look some more at these in just a minute. In order to find c for an ellipse, we use one of the two formulas. C equals square root of a squared minus b squared, or c equals square root of b squared minus a squared, depending on whether a or b is larger for that particular ellipse. We'll look some more at that. And for hyperbola, c equals square root of a squared plus b squared. You can also think of that as c squared equals a squared plus b squared. Okay, let's go ahead and get started with a problem. The first problem here being to find the standard form of a circle having endpoints of a diameter at -3, 5, and 2, -1. So we'll begin by graphing the parts of the circle we know something about. We know that we have endpoints of a diameter at the point -3, 5, and 2, -1. Okay, so I'm just going to make a dashed line between these 2 points, indicating the diameter here. And then we would have a circle. We'll just do a quick, probably kind of sloppy sketch here of a circle. But what we're talking about here is that we do have some circle with this diameter down the center of it. Okay, so let's go ahead and think of the equation of a circle would be x minus h squared plus y minus k squared equals r squared. If we find the center hk and the radius r, we've got it. So let's start by finding the center. To find the center here, basically, we just need to find the midpoint between our endpoints of this diameter. So to find the midpoint between the points -3, 5 and 2, -1, we take the average of the x-coordinates, -3 plus 2. We just take -3 plus 2, divide by 2, and the average of the y-coordinates, 5 plus -1, we divide 5 plus -1 by 2 to get that number. This gives us a center of -1/2. What we have 2, it looks like. So our center, our HK here, is -1/2, 2. So I'll mark that on our graph here. So -1/2, 2, about right there. Okay, next, to find the radius, if we can find the distance from the center to either point at the endpoint of a diameter, I have the radius. So to find the radius, let's just take the distance from, let's say from the point -3, 5 to the point -1/2, 2. If you remember the formula for the distance between 2 points, we would take x sub 2 minus x sub 1. So let's just say our x sub 2 is -3. So -3 minus -1/2 squared plus y sub 2, 5 minus y sub 1, which would be 2 here, 5 minus 2 squared. And so we'd have the square root of -3 plus 1/2. Negative 3 plus 1/2 would be negative 6/2 plus 1/2, negative 5/2 squared plus 3 squared. And so what do we get? We get the square root of 25/4 plus 9. And let's see, if I write 9 as 36/4, that gives us a radius of the square root of 61/4, and I think that's good enough for right now. Let's go ahead then and write our equation. Our equation would be x minus a negative 1/2, which would be the same as x plus 1/2 squared, plus y minus k, which is y minus 2 squared, equals r squared. So if r is square root of 61/4, r squared would be 61/4. And we have our equation. All right, so let's go ahead then and look at our next problem of the day. And we're moving on to looking at an equation of a conic section, and we're going to take this equation and put it into standard form. So the equation we have here is 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. It helps to look at what type of conic section we have before we get started. If we have an x squared and a y squared, we know it's not a parabola. And if we have a plus in front of the 9x squared, a plus in front of the 4y squared, then we know that it's not a hyperbola. And so I'm guessing that this is an ellipse, being that 9 and 4 are it would not be a circle because we have a different coefficient on the x squared than we have on the y squared. So if we have an ellipse, let's go ahead and see if we can get this formula written as an ellipse. And so I'm going to start by writing 9x squared. I'm going to put my x terms together. 9x squared minus 18x plus 4y squared plus 16y. I'll put my y terms together, and then I'm going to add 11 to each side. Okay, so 9x squared minus 18x plus 4y squared plus 16y equals 11. I'm going to factor out the coefficient on the x squared and the coefficient on the y squared. Let's just throw some parentheses around the x's and then around the y's. So I'm going to factor 9 out of 9x squared minus 18x to give me 9 times x squared minus 2x. And then I'm going to leave some space because I think we can add another step here in just a minute. I'm going to factor out 4 from the 4y squared plus 16y to give me 4 times y squared plus 4y. And then again, leave a little space here. We have equals 11. And then let's see what numbers we need to add here to complete the squares. So x squared minus 2x, I take half of the negative 2 and square it to give me plus 1 here. Okay, but I can't just go adding numbers to one side of the equation. I need to add the same number to the right side that I added to the left side. What I really added to the left side, though, was 9 times 1, not just 1. So I need to add 9 to the right side of my equation. And then for the y's, to complete the square on the y's, I need plus. I take half of 4 and square it, which would be 2 squared, or 4 again. And then what we're actually adding here is 4 times 4, or 16. So I want to add 16 to the right side of the equation. We can finish off our equation here. The next step would be to write this as 9 times x minus 1 squared plus 4 times y plus 2 squared equals 36, I believe. Okay, and so let's make this look like an ellipse. We want a 1 on the right side of the equation, which means I want to divide both sides of my equation by 36. And on the left side, that would be equivalent to dividing 9 times x minus 1 squared by 36 and dividing 4 times y plus 2 squared by 36. So we end up with x minus 1 squared over 4 plus y plus 2 squared over 9. And you can work on simplifying this yourself to make sure we did that right. We have our equation. X minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. We'll start graphing by first noting that for the ellipse, the center is hk, x minus h, y minus a negative 2 will give us a k value of negative, oh, what am I doing? Okay, yeah, the center is hk, but let's see. I meant to actually write what the center is here. Okay, so the center would be 1, negative 2. Okay, let's go ahead and plot it. The point 1, negative 2, right here on our graph. We have the center. And then to find, we notice that under x minus 1 squared, we get a squared equals 4. That gives me an a value of 2. From the center, for my graph, I'm going to go to the right 2 units and to the left 2 units. So a is always in the x, the horizontal direction. So from the center, we go to the right a distance of a, to the left a distance of a. And then we also note that b squared here is going to equal 9. And so b would be equal to 3 here. And so from the center, we're going to go up a distance of b, 1, 2, 3. Except I can't count, so let me fix that. Okay, so we go up from the center, 1, 2, 3. That would bring us to 1, 1. And from the center, we go down 3 units. We basically can sketch our ellipse here. Just connect the dots with a nice smooth curve. Let me fix that one part. Okay, well, it's close. It's not perfect. Ellipses are kind of like egg-shaped, right? Okay, so we have our ellipse drawn here. The only other thing I'd want to find, so I found that the vertices, right? This is a vertex right here, and this is a vertex right here. We can call them vertex 1 and vertex 2. Vertex 1 would be the point 1, 1. Vertex 2 would be the point 1, negative 1, 2, 3, 4, 5, it looks like 1, negative 5. We also sometimes are asked to find the foci. So let's go ahead and do that here. It's just good practice. We'll try to do everything we can to get you ready for the exam. So to find the foci, we need to figure out what C is. So C is going to be the square root of a squared minus b squared, or the square root of b squared minus a squared. In this case, you notice our ellipse is elongated in the y direction. Here, b is bigger than a. And so we're going to take c is going to be equal to the square root of b squared minus a squared. And that would be the square root of 9 minus 4, or the square root 5. So if on an exam you're asked to find the foci, we would go from the center up a distance of square root 5. It'd be a little more than 2. This would be focus 1. And then we would go down from the center a distance of square root 5 to give us focus 2. So our foci are, the center is at 1, negative 2. So from the center, we'd stay at x equals 1, but we'd take negative 2 y value of the center, and we'd add square root 5 to give us the first focus. We'd leave our x coordinate as 1 for the second focus, and we would take negative 2 minus square root 5. Okay, so in addition to graph, we've done just about everything we can do with this problem. We found the foci, we've graphed, we found an equation in standard form, so I think we're good. Let's go on. And now we have another equation, and we're going to find the standard form and graph this conic section. We have y squared minus 6y plus 4x plus 17 equals 0. Notice that we only have one variable squared here, the y. That means we're going to have a parabola, and we're going to put this parabola in the form y minus k squared equals 4p times x minus h. And you can refer back to your formulas for this. So let's start by getting the y's on our left side of our equation. Y squared minus 6y equals everything else on the right, negative 4x minus 17. And we'll complete the square on the y's. So y squared minus 6y. What number do we need to add to the y's there? It looks like if we take half of negative 6, we get negative 3. If we square negative 3, we get 9. So we're going to add 9 to both sides of the equation and then just clean things up a bit. We have y minus 3 squared equals negative 4x minus 17, negative 17 plus 9. What was 8? Negative 8. Okay. Negative 4x minus 8. Okay. So let's go ahead and try to get our equation so it looks just like we have up here. We have y minus 3 squared equals, we're going to factor out a negative 4. And then we have negative 4 times x plus 2. Okay, so what do we know from this? We know that our vertex is hk. And that would be equal to here, x minus h would give us a negative 2 for the x coordinate of the vertex, and y minus k would give us 3 for the y coordinate of the vertex. So we have negative 2, 3 right here. Here's our vertex. And let's see what p is here. So we can see that 4p is going to equal negative 4. That tells me that p equals negative 1. Okay, so with y appearing first in our formula here, we're going to open either left or right. If p is less than 0, we're going to open to the left. Okay, so this p equals negative 1 tells me from the vertex here, I'm going to open to the left. And the P also tells me how far I go to the left to reach the focus. So, and I forgot to, up here, actually, we have our formula in standard form right here, so I didn't circle that. But our standard form is y minus 3 squared equals negative 4 times x plus 2. We have our vertex. We're opening to the left because p is less than 0. We go a distance of 1 to the left, giving us a focus right here. So let's see, we wrote down what the vertex is. To write down what the focus is, we would have what? The vertex was negative 3, 2, or negative 2, 3. The focus is going to be negative 3, 3. I like to add things as we're going through these. So we have the vertex, we have the focus. Another thing I could add here before I finish graphing is the directrix. So for the directrix is a line. And instead of going to the left by 1 unit to get to the focus from the vertex, if we go to the right by 1 unit and sketch the line, in this case, the vertical line, this would be x equals negative 1, and that actually is our directrix, the line x equals negative 1. Okay, so we have the focus, we have the vertex, we have the directrix, and now let's sketch this thing. So to sketch a parabola, once we have the focus, we're going to go And remember, we basically have we do have an axis of symmetry going on here. So through the vertex and through the focus, we have an axis of symmetry. Our axis of symmetry in this case would be the line y equals 3. So if we look at the axis of symmetry, we're going to go a distance of 2p from the focus, up and down. So if p equals -1, we're going to go a distance of 2 times 1 up, or 2 up and a distance of 2 down. These give me the endpoints of the lattice rectum. So we go up by 2 times the absolute value of p. We go down by 2 times the absolute value of p to get the endpoints of our lattice rectum. And then we can finish sketching this parabola here by going through the vertex, through the endpoints of the lattice rectum, with a nice smooth curve. And the endpoints of the lattice rectum really give us the shape of our parabola, because our parabola could have all kinds of different shapes going on here. So it could be skinny or it could be wide. This gives it a lot more definition. It's fairly easy to do. So, okay, let's go on. Our next problem is to find the standard form and graph the conic section -4x squared plus 9y squared plus 16x plus 18y minus 43 equals 0. The first thing we're going to do here is note that because we have a -4x squared, a positive 9y squared, we have different signs here for the x squared and the y squared. We're going to have a hyperbola. Okay, so to graph a hyperbola, let's put the positive 9y squared first, or to get the equation for a hyperbola in standard form. We have 9y squared plus 18y minus 4x squared plus 16x equals 43. Again, I'm just going to throw that constant over on the right side. So I'm going to rewrite this before we start cleaning things up here. So I have 9y squared plus 18y plus -4x squared plus 16x equals 43. Okay, so from the y terms, I can pull out a 9. I'm going to have 9 times y squared plus 2y, leave some space, plus from the x's, I'm going to pull out a -4, factor out -4, and I'll have -4 times x squared minus 4x, leave some space, equals 43. And then let's see what we need to add here to complete squares. So for the y's, I divide 2 by 2 and get 1. 1 squared is 1, so we have y squared plus 2y plus 1. What I'm really adding here, though, is 9 instead of 1. So I'll add 9 to the right side as well. For the x's, x squared minus 4x, if I divide -4 by 2, I get -2. I square -2 to get 4. So x squared minus 4x plus 4. But instead of adding 4 here, what I'm really adding is -4 times 4, which would be -16. So I'm going to subtract 16 from the right side to keep my sides equal. Okay, our next step then is to write the squares in completed form. 9 times y plus 1 squared minus 4 times x minus 2 squared equals 43 plus 9 would be 52. 52 minus 16 would be, let's see, 36, I believe. Yeah, so 9 minus 16 would be -7. Yep, that looks right. Okay, so 36. And then let's divide both sides by 36 to get it into the form of the hyperbola that we're used to seeing. So if we divide by 36 on the right side, we'll distribute through to both terms on the left side to divide through by 36. And so we end up with y plus 1 squared over 4 minus x minus 2 squared over 9 equals 1. So we want a 1 on that right side. Okay, so y plus 1 squared over 4 minus x minus 2 squared over 9 equals 1. We have our formula for the hyperbola. And the first thing I'm going to do is graph the center of the hyperbola, which I get from x minus 2 squared. That would give me x minus h would be 2. Y plus 1, k would be equal to negative 1 here for the center. And I should maybe write what the equation of this hyperbola is. It's y minus k squared over b squared minus x minus h squared over a squared equals 1. So our center is hk. And so we have our center 2, negative 1. The next things of interest in graphing this hyperbola are to figure out what a is and what b is. So here a is underneath the x, like always. So a squared would be 9. So a is going to be equal to 3. So I use this a I'm going to make a little box to help me sketch my hyperbola. So coming out from the center, 3 units in the x direction, in the horizontal direction, brings me to right here. 3 units to the left brings me right here. So that takes care of, and we'll finish off our box when we figure out what b is. Well, we can see that b squared is underneath the y plus y minus k squared. So here b squared is going to equal 4. That tells me that b equals 2. Okay, so if b equals 2, from the center, we're going to go up 2, and we're going to go down 2. And then I'm just going to use a dashed line to make a little box that includes my a distances and b distances. And I'm really interested in the corners of this box. Okay, now from the center, I'm going to sketch some asymptotes that go through the centers and through the corners of this box. Now let's make our asymptotes light blue here. Okay, here's our first asymptote. You can figure out what the equations are of these asymptotes if you figure out, use your formulas for lines. Finding 2 points on the asymptotes would do it for you if you need to review that. And then, okay, so where are we at? We have our asymptotes drawn. What I need to know is in which direction are my vertices. Okay, so I know what the center is, but with the ellipse, you know, if your ellipse is elongated, the vertices are always going to be in the long direction. If it's longer in the up and down direction, your vertices will be up and down. If it's longer in the horizontal direction, your vertices will be left and right. That doesn't quite work with hyperbolas. So what we need to do with hyperbolas is we need to look at whether y or x comes first. And if y comes first, like it does here, then our hyperbola is going to open up and down. So let me erase the ellipse notes we have here. So if y comes first, and because you have a minus here, you're definitely going to have either y coming first or x coming first. If it's y that comes first, your hyperbola is going to open up and down. That means from the center here, we can go up to find a vertex here. And from the center, we can go down to find a vertex here. Okay. I'm looking at my notes I made for this, and I made some mistakes in my notes. I hope this is correct. For somehow I put b equals 4, but b squared is 4, so b should equal 2 unless I've made a mistake. So I think this is right. Okay, so let's go ahead and sketch our hyperbola. It's good to have notes if you make a mistake and then you see that your notes had something else, but if you have mistakes in your notes, I don't think they're all that helpful. Okay, so here we go. See what a nice shape this gives us by approaching those asymptotes? And we have our hyperbola. Okay, so what have we done? We've graphed the conic sections. We found the standard form. We actually have found the vertices. So our vertices are what? Our vertices are 2, 1, and 2, 1, 2, 2, negative 3. All right, so we have our vertices. What we don't have is our foci. Let's go ahead and do that. And I'm not going to refer to my notes because I'm sure they're pretty messed up with the foci since everything else seems to have been off here. Okay, but let's find the foci by first finding what C is. So hyperbolas are really nice. So to find C, you can always use C squared equals A squared plus B squared. Okay, so in this case, our C squared is what we're trying to find. And we have A squared is 9 and B squared is 4. So C squared equals 13. That means C is going to be equal to the square root of 13, which the way I think of this is square root of 13 is a little bit less than square root of 16. It's a little more than square root of 9. So C is going to be between 3 is going to be less than C is going to be less than 4. It's between square root of 9 and square root of 16. And so if from the center we come up to get to our focus, our first focus, we'd come up a little more than 3 units, up here somewhere. This would be focus 1. And from the center we go down a little more than 3 units. Down here, here would be focus 2 somewhere. So what are the coordinates of those foci? Well, let's see. Our center is the point 2, negative 1. So if to find our first focus, we're at an x value of 2, and then we have negative 1 plus square root 13 to give us our first focus. Our second focus would be at negative 2, or at 2 for an x value. And then we'd take negative 1 minus square root of 13 to give us that second focus. Okay, well, let's move on. I think we've done all we can do with this. And the next thing we're going to do is we're going to find some equations for, first of all, a parabola with vertex 6, 5 and focus 2, 5. My suggestion is, before anything else, if you're given a couple what would you call them, things that you know about a parabola or whatever conic section you're working on, put those on a graph so it'll give you a better idea of what's going on. So let's start by we have an x and y axis here. Here's our x-axis, here's our y-axis. We'll just throw these points on our coordinate system. We have a vertex of 6, 5. So this is our vertex at 6, 5. We have a focus at 2, 5, about right here. So we have a focus at 2, 5. I don't necessarily need to graph these here, but if I graph just this much of them, it gives me a really lot of information. So what does it tell me? Well, it tells me one thing, that if my vertex is at 6, 5 and my focus is at 2, 5, my parabola is going to go through the vertex and it's going to wrap around that focus. So it's going to be going this direction to the left. If my parabola goes to the left, then I'm going to use the formula y minus k squared equals 4p times x minus h. Okay, and I know that my vertex gives me my HK here, right? So my vertex gives me HK. So from that I have y minus 5 squared equals 4p times x minus 6. And we need to figure out what p is. Well, guess what? The focus gives us a whole lot of information here. So to find what p is, the distance between the vertex and the focus gives me p. So here p is going to be, it doesn't tell me if p is positive or negative though. So it tells me that p is either plus or minus the distance here going from 2,5 to 6,5. I go a distance of 4 units. So to determine if p is positive or negative, well, if my parabola is opening to the left, that tells me that p is less than 0. Opening to the right would give us p is greater than 0. So we're going to have p is going to be equal to -4. Okay, so if we know that p equals -4, we can continue on with our formula. We have y minus 5 squared equals 4 times -4 times x minus 6. So y minus 5 squared equals -16 times x minus 6, and we have it. All right, so let's go on. We could graph this, but I think we're good. So let's go on to number 6, where we're finding an equation for an ellipse that has a center at 7,3, a focus at 4,3, and a vertex at 12,3. So ellipses are nice. There's only one formula we can use here. It would be x minus h squared over a squared plus y minus k squared over b squared equals 1. And again, like we did in the last problem, I have some information about the ellipse, and if I just throw that information on a graph, I think it will make my life a lot easier. So let's just plot those points. Try to get a graph that's somewhat straight here. Okay, and it looks like everything's positive here. So let's say this is x, this is y. So we have a center at 7,3. This is our center. We have a center at 7,3, a focus at 4,3. So I'll just put F for focus. And what else do we have? We have a vertex at 12,3, so about right here. This would be a vertex at 12,3. Okay, so what do we know from this? Well, we have the center, that gives us HK, so I can write x minus 7 squared over a squared plus y minus 3 squared over b squared equals 1. We need to figure out what a and b are. Well, I do know that the distance from the center to a vertex, from the center to a vertex, I have a. Okay. So let's see, from 7,3 to 12,3, that would give me a equals 5. Well, we can go ahead and throw a into our equation. We have x minus 7 squared over 5 squared. But we don't know what b is, do we? So, well, the distance from the center to a focus, though, what does that give me? That gives me c. So here c would be equal to, we're going from 4,3 to 7,3, so c would equal 3. Okay, so with an ellipse, we need to take either have c equals square root of b squared minus a squared, or we have c equals square root of a squared minus b squared. The way we figure that out is this ellipse is going in the horizontal direction, which means, and we can tell that because we have a vertex right here. The vertice, the center, and a focus are given to us here. So we know that the major axis then is going in the horizontal direction. If the major axis is in the horizontal direction, then we know that A is going to be bigger than B. Okay, we really need to know that when we work with this, because if we use the wrong formula down here, we'll get the wrong value for B that we're looking for in this case. So we know that A is bigger than B, so we're going to use C equals the square root of A squared minus B squared, from which we get C, which is 3, equals the square root of A squared, which is 25, minus B squared. We'll square both sides to give us 9 equals 25 minus b squared. Subtracting 25 from each side, we get negative 16 equals negative b squared. So b squared equals 16. That's really all we need. We can see that b equals 4, but all I'm trying to fill in here is b squared. And we end up with a final formula, x minus 7 squared over 25 plus y minus 3 squared over 16 equals 1. And we have it. So that's our equation for an ellipse. Okay, we move on to an equation for a hyperbola. We're trying to get everything in here so you're good and ready for an exam. A hyperbola that has vertices. Again, let's sketch a picture and see what's going on here. So we have vertices at plus or minus 4, 0. So here I have a vertex, here I have a vertex. And we have foci at plus or minus 8, 0. So with hyperbolas, that the foci are farther out, generally speaking, than the vertices. So we're coming out 4 more to give us a focus here. And 4 more to the left to give us a focus here. So we have our vertices and our foci. And we can see the center is going to be right here in the middle, right? So we know a couple different things here. So if we have our vertices and our foci going in the horizontal direction, then we know that our hyperbola is going to be opening like so. And that tells us what formula we need to use, right? So opening to the left and right means that we're going to use the formula x minus h squared over a squared minus y minus k squared over b squared equals 1. And so the center, being right between vertex 1 and vertex 2, is going to be at the origin. We can actually refine this formula a little bit, putting 0 in for h and k. We have x squared over a squared minus y squared over b squared equals 1. Okay, and let's figure out what A and B are. So I think we have A, don't we? So A is the distance from a center to a vertice, which would be 4. So A equals 4. We don't know what B is, but we do know what C is here. C is the distance from the center to a focus, so C would equal 8. Okay, so to finish off here, we need to figure out what B is. Well, the hyperbola is the nice one, uses c squared equals a squared plus b squared. And so here c squared, c is 8, so 8 squared equals a, which is 4, 4 squared plus b squared. We have 64 equals 16 plus b squared. So subtracting 16 from each side, we get 48 equals b squared. And so I think we have everything we need to finish off our formula. So let's do it. So we have x squared over a squared. If a is 4, then a squared would be 16. Minus y squared over b squared, which we found was 48, equals 1. And if you wanted to, you could go ahead and sketch this graph, but we have quite a bit of it started. It wouldn't be too hard to finish off, but I think we'll go on. We have a couple more problems to finish off. The next problem here is a whispering gallery problem. The whispering gallery is built so that its cross-section is shaped as half of an ellipse. Okay, so in other words, the whispering gallery looks something like this, half of an ellipse. Okay, the length of the whispering gallery is 120 feet, and the foci are located 35 feet from the center. All right, so we're going to throw this on an XY coordinate system. So let's say y is this direction and x is this direction. I know in your homework they put these in kind of strange positions, but this is where I would usually locate these. And if the length of our whispering gallery is 120 feet, then we would have a point, what would this be? Splitting 120 in two, we'd have the point along our x-axis of 60, 0, and also another point, negative 60, 0. And let's see, the foci are 35 feet from the center, so these would be vertices. So this would be vertex 1, vertex 2. The foci would be located at negative 35, 0 and at 35, 0. Okay, so we're trying to find the height of the ceiling at the center. So right here, we're looking for what the height is at this point. And if we look at this graph-wise, this would be the point on our ellipse that would be 0 from where I located the intersection of my x and y axes, the origin. This would be the point 0h for the height. The height of the ceiling at its center would be right here. Okay, so we have an ellipse. What do we know about this ellipse? Well, we could come up with an equation if we wanted to. Our ellipse is elongated in the horizontal direction. But really for an ellipse, we use the same equation in either case. The one thing that's nice here is we have the center of our ellipse is at the origin. Okay, so we're going to, if we have x minus h squared over a squared, then h is 0. So we're just going to have x squared over a squared plus y minus k squared would be y minus 0 squared over b squared equals 1. And from looking at what we have going on here, we can see that a is 60. So we'd have x squared over 60 squared plus y squared over, we don't know what b is, but look, we do know that b is h, right? So let's just call b h here. So 60 squared, x squared over 60 squared plus y squared over h squared equals 1. And do I know a point on this ellipse? Well, actually, what are we still looking for? We're trying to find h, but we know that h is the same as b, don't we? So if h equals b, we probably don't even really need the equation here. I see that from the center, I get to foci 1 and foci 2 by going a distance of c. So here c would be 35. And if I just need to find what b is, basically, I have a is 60, c is 35. we can see that our major axis goes in the horizontal direction, which tells us that A is going to be bigger than B. And so if A is bigger than B, well, I can use C equals the square root of A squared minus B squared, or 35 equals the square root of 60 squared minus B squared. Let's just solve for B, and we've got our height. So squaring both sides, we have 35 squared equals 60 squared minus B squared. So 35 squared minus 60 squared equals negative B squared. So what would that give us? Let's see if 35 squared minus 60 squared. This would be 1,225 minus 3,600, from which we get negative 2,375 equals negative B squared. B squared would be positive 2,375. And if we plug that in a calculator, B is going to be approximately equal to 48.73 feet. Okay. So we have B, and actually B is h. So our height at the center is about, or approximately about 48.73 feet. And this will be our answer here. Okay, let's go on. One more problem to go today. A parabolic arch has a span of 150 feet and a maximum height of 12 feet. So this is similar to the problem we just did. We have a parabolic arch, something like this. And we have a span of 150 feet. So let's again throw this on an XY coordinate system. And I like to put the base of this parabola on the x-axis, and then the y-axis passes through the center, so to speak. So our parabolic arch has a span of 150 feet. That means if we center it at the origin here, we're going to have two different points on this arch, the point 75, 0, and the point negative 75, 0. Okay. And then we have a maximum height of 12 feet. So our maximum height of 12 feet tells us right here at the vertex, we're going to have the point 0, 12. Okay, so we put down on here what we know. What we're asked to find is to determine the distance from the center at which the height is 10 feet. So we're trying to find somewhere on here, our height is going to be 12 feet. And we're trying to find what this distance is, at which point we have a height of 12 feet. On the parabola itself, this would be the point on the parabola D, and the height here is 10, so it would be the point D10. So I think for this one, we do need to figure out what the equation of our parabola is. Okay, so if our parabola opens down, like this one does, we have the formula x minus h squared equals 4p times y minus k. Our vertex here is 0, 12, which gives us our h and our k. So we can go ahead and plug in an h value of 0. We have x minus 0 squared equals 4p times y minus our k value of 12. Okay, so we have our start of our formula. We need to figure out what p is. And to figure out what P is, I have a point on this parabola. It's the point 750. I actually have that point negative 750 as well. But let's use this point 750, plug in 75 for X, 0 for Y, and see what we end up with. Right now, we have X minus 0 squared, which is X squared, or 75 squared equals 4P times, we're plugging in 0 for Y, 0 minus 12. 75 squared is 5,625. So 5,625 is going to equal negative 48P. Okay, we need some more space here. So P is going to equal negative 5,625 over 48, which we can simplify just a little bit, dividing through, I think, by 3 in the numerator and denominator, we get negative 1,875 over 16. And now we can rewrite our formula as, right here, we can plug in P. So we're going to have X squared equals 4P, where P is negative 1,875 over 16. Negative 4 times P times Y minus 12. Okay, so simplifying just a bit, we have X squared equals negative, and we take 4 over 16 is like 1 over 4, so negative 1,875 over 4 times Y minus 12. We're almost finished. We just need to plug in that point of interest right here. We're plugging in, whoa, I don't want to lose things now. Right here, we're plugging in X, D for X, 10 for Y. So we have D squared equals negative 1,875 over 4 times 10 minus 12. And we can solve for D squared there. And we basically, if we solve for D squared and then we take the square root of both sides, we're going to end up with D is approximately equal to 30.62 feet. Okay, so the distance from the center at which the height is 10 feet would be approximately 30.62 feet, which makes somewhat sense looking at our picture. And it's always a good idea to go back and take a look at your picture. Anyway, in addition to what we've just done here, work through the worksheets when you're getting ready for the exam, and go back, maybe look at some problems that you've done in homework or whatever extra practice you need here to help you get ready, along with review the concepts that would be covered on this exam. And I wish you the best.